Hi everybody, Dmitris here. So in previous videos we looked at rig light position calibrations, we look at creating ground control points, we build a simple color chart prop and look at the simple 2D material reconstruction pipeline as well. So finally let's go ahead and build our hero prop that was an octopus. To do that, so in our props, let's copy paste our prop template and call it Octopus. Octopus, and let's call it RC, reality capture version, and I misspelled it. There you go. Because later on we'll also be building the same stuff using Metashape and other packages. So in this case, let's go back to where our capture data is, to props, and this is where our octopus starts, and there's sirens outdoors. Don't know what's going on there. So there you go, we got 1464 shots there. Let's go back to the Octopus prop EOS folder. Let's paste everything in here. And that's the source data as it was copied and recorded by the camera. We can quickly check and calculate if we have 1154 shots divided by 24, that's 12 times 4, that's the size of a single sequence. So we have 48 sequences there divided by 3, and each one was 16 steps each loop. So we had 3 loops, 16 steps each, and 24 shots in there per sequence. So let's go ahead and run our fold script. So at this point everything is organized in these folders, and you can see there is also some separation between loops. So it looked at the EXIF data and some basically gaps in time between different loops. It also split it so we can clearly tell that this is loop number 1, number 2, number 3, and the total index of the shot. So at this point that looks good. Let's go ahead and run this generate PG image script. As I said, what that does, it goes through all the images and generates synthetic images that we will be using with photogrammetry process. Some of those images are well suited for alignment process, and other sets of images are better suited for depth map reconstruction and mesh reconstruction in general. But for a basic version of kind of reality capture pipeline overview, we'll be using just the same image set for both alignment and geometry reconstruction. But in this case, geometry, it's enough. 3 loops is good enough. And the reason we do 3 loops is that we want to have those cameras to form 3 perpendicular planes. They don't have to be perfectly perpendicular, but that would be equivalent of having cameras observing the prop from basically all possible directions. Another alternative, of course, is to just tilt the whole rig up and down, but at some point you would still have to flip it to get the bottom and probably the top, the rest of the top. So this process is quite CPU heavy, so at this point it's good to have quite enough cores there in your system. Still goes pretty quick. We have progress bar here at the bottom. It says 64%, and all the images basically are written over here. And the rest of the file here, we have basically batch files and other files to better, so it's less confusing. We can group by type. And some of these files here are just dummies, so when we override them, we don't make a mistake accidentally when typing. It took about 3 minutes. This window will close in 1 second by itself. So now if we go to images, and we see all our footage in here. When scanning this, I did point out that at this point you try to put your objects so that later on you would have to do less work separating it from the rest kind of the scene and the support structures. This is the case where you can see that our kind of like this alignment box is partially occluded, and this is why it's good to have kind of multiple few smaller markers on there. So you could see that. Now when it's rotated, we most likely are going to see problems when this box attaches to some parts of this model. Different packages, photogrammetry, treated differently. In Metashape, it's a bit easier to work with because it will have that you would have a better separation there. With the Metashape, what we will see later, there will be problems there. And in this case, ideally you want to avoid this situation. Like for instance, in this case, this part, we'll see that it is partially overlapping there. For this model, we can ignore it because it's a relatively small problem, but in general we would have to mask it out, this whole region, to make sure that this support structure does not interfere with material and texture reconstruction in general. But here we have it. So this is roughly what all these loops and the data looks like. Let's run the Metashape, and first I was thinking whether to show you like the quick fast process or the process that you most likely will run into, and then have a chance to explain a number of things, and we'll probably do the later. So that you can kind of see why certain things are done when you scan the object, and you want to take care of some things at that point, so that later on your life is easier, and how to deal with problems later on in the process. So let's go ahead first and assume that we just build in prop for the first time. We know nothing about the problems that we might have. Let's just open all the images. Let's make sure that they all in the same calibration group. Yes, that's all good. Now let's go to alignment, detect markers. We do have markers here. Let's take advantage of that. Detected markers, markers detected. We have 19 of them. That's good. Let's import ground control, our main box. Okay, there you go. All of them are in there, and apparently some ones like an unassigned because they probably don't exist, and other ones like this is definitely clearly a not a good one. And we just remove those. Again, you don't need to remove them, especially one of these with just one image. They're either misdetected, or it's just a single image, and from that you need at least two. So anyway, that's all good. Everything that I've just done there, clicking, you don't really need to do that. So let's go ahead and click align. The most important thing here is to make sure that it is actually aligned properly, because as I said before, it might, if it generates more than a single component, then most likely there are problems. We need to play with settings. even if it generates a single component and it says that everything is aligned, you might have some outlier cameras that just point like clearly not on the circle of the loop. That would be wrong. In that case, you might just delete component and run alignment one more time. So there you go, we got that. Great, we have one component, we have 48 out of 48. That's great. Let's go to view scale our cameras so we can see them. Too big. There you go, looks like one loop is good, another one perpendicular is good, and that one is good as well. So these let's hide these names. We might also, sometimes it's useful to look at all that stuff in parallel view, because in this case you can clearly see these loops and these perfect circles. So there you go, we have our model that's also nicely placed on the ground. It's a bit elevated because it was scanned like on a little bit of extra support there. Let's go ahead and I moved the reconstruction region. Let's put it back, and let's build a preview model. Sort of looks alright. Here's however where the problem is going to be. Let's now go ahead and build normal detail mesh, because when we build a preview, it builds it from those sparse type points, and that's not the same algorithm that is used for main reconstruction. There you go. The process has finished. So we got our high poly mesh, and let's see if we have any problems. And this is what I was talking about before. We have this problem where part of this and I forgot what is the part of his leg. What's the limb? Damn, I forgot. Tentacle. There you go. Part of this tentacle is joined with some of these support structures that we have here, and if this is the only problem, it would be relatively. Oh no. Yeah, there you go. So there's this other one problem that it's also joined like that, and unfortunately, it's other photogrammetry packages don't do that. But reality capture in the latest version seems to do that. Let's see what algorithm we used. So yes, this is version 1. So okay, this is what we had before. Let's go ahead and try version 2 and see how that is going to be different from this, because essentially in this case we have to go ahead and for each loop build the same stuff, build a mask, remove all the stuff that should not be there, and that's how you do it. So let's try algorithm number 2. There you go. We're almost done with algorithm number 2, and this is the moment of truth. Do we actually have to go ahead and deal with those masks and loops, or it will resolve those connections better? And unfortunately, it's probably a little bit better. Yeah, it's definitely better. It's definitely better than what we had before. What's the difference between them? Yeah, the second one definitely looks a bit smoother, and would probably Definitely wanna use that, though some things I'm not sure about. Maybe it's sort of like close enough. So we had in our first scan, so there was that problem, and that's definitely a problem. In this case it's quite a bit less, so I think we could, just for this model, I'll probably do separate than video on masking, because we can just cut it off and close the hole. And in other case, because the second algorithm is definitely better than the first one, and this was another problematic area. And as you can see, it's in this case you try to scan it and place it such that you want to minimize these things, but sometimes it's just not possible. Yeah, this one is definitely better. So what we're gonna do for this part of the tutorial, I'll just go ahead and remove all this stuff manually. We close some holes and go from there, and then in the next video I'll show you a different version, or where we'll go ahead and generate masks and treat all these loops separately. But overall, this model is something that we can work with. Let's go ahead and save our model, call it Octopus RC, let's call it 01, save. Great. So now let's do some editing on this model. Let's well, we'll keep the other stuff in there. Let's hide the grid. And what else do we need? That's probably good. So right now it's a bit annoying stuff that will take a while, but we need to remove all this stuff that we don't want in here. Filter selection. That as well. Filter selection. And every time it creates a new mesh, that's fine. Don't really want that. So let's try and cut it off more precisely. Will that do it? Maybe not. Let's cut it a bit more like that. Is that better? Probably a bit more, even something like that. And I hope that that close hole thing will take care of that. Filter selection. Okay, what else we have left? So this is the stuff I was talking about. When you place it carefully, then it's super easy. You just select like that and it's done. This was that other problematic area that we had in using algorithm number 1. So in this one it's definitely better. but there are still problems. What else? That little thing has to go as well. There you go. Is that good? Filter selection. And let's see. Do we have any other obvious problems here? Definitely in this algorithm number 2, I'm not liking some of that stuff. That's definitely not what the model looks like there. I think in algorithm, and my camera is gone. What was that before? In number 1. Yeah, as we'll see later in meta shape, you get much better quality there out of the box on these meshes. So that's good enough for now. That's our prop. Let's try and close those holes. Let's find one of those areas. Yeah, that one, but we had another one. Where was it? I cannot find it anymore. Where was that? That's the area. No, there was another area. Where is it? This one. So we cut quite a bit there. Let's see if it can handle that. Close holes. Let's try it again. Close holes. Let's see if it saves us. It did something. It's a bit weird shape there, but that's better than nothing. Let's see if we can smooth it out, just that part, because that would look a bit better if we could just smooth this part out. Smoothing tool, smoothing style. I don't know, is it going to do just the selection or everything? What do you think? Okay, let's try it. I only wanted the selection. Did it do just that? Hard to tell. I don't know. But see, it's hard to also do A and B in here because it keeps re-rendering. And let's on this one, since it's already selected, let's try something extreme. Smoothing tool. I get lost when it shows me more than what I need. So smoothing iterations, 200. Why not? Strong. Okay, go. I think it did the selection. Otherwise, everything would be busted now. but okay, I think we'll go with that. Let us save the file. That's our high poly mesh. Technically we don't need, I think if we go to suite, no, there was wireframe mode, no, I don't see the wireframe there. Vertices, no, I don't want that. Hard to see. Anyway, currently it says 10 million triangles. Let's downscale it to 5 because usually, again, here it's hard to tell, but we don't need all those 5. So let's go to simplify tool and we'll do 5 million. 5, 1, 2, 3. Yep. Simplify. May contain topology defects. Yeah, okay, cool. There you go. Simplification is done. We have 5 mil model. Let's rename it so we know what we're dealing with. So at this point, alignment. Go ahead and export registration. Make sure we are working in the right directory. And RC cameras, yes, okay, exported. Now let's export this this high poly model, mesh, props, Octopus, PG. We switch to PLY file, high poly. Do you want to replace it? Yes. Save mesh by parts? No. Save it as a single chunk. Export normals? Yes. Colors? Sure. Though we don't need any colors there. There you go. And now let's generate our low poly mesh. We don't need 5 mil there. Go tools, simplify. Let's do 200K. That's more than enough for this model. Simplify, yep. So there you go, we got our mesh, low poly, let's call it low, and on top of just the geometry we also need to do unwrapping. Unwrap, Glider 2, max is 8K, that's fine, all that is fine, so maximal texture count 1. We do 1 unwrap. That's done. Let's assign a checkerboard to it. Make sure we don't have some weird stretchy things or other types of obvious artifacts. It would obviously help if this color checker thing was not so dense. But we got what we got. So I think overall I'm happy with that. We can proceed. Obviously when doing stuff for more specialized things like video games and VFX, if you want to animate something, you might have to use different tools like ZBrush for cleaning and better UV mapping, sometimes like user guided, where you put seams, and so you get nice UV charts and things like that. And if you want to animate, you might want to have to do retopology using quads and things like that. In this case, we're just using as is whatever is available in our photogrammetry packages, and stuff like that is usually good for any e-commerce stuff where you just render things and don't really worry or care about what the actual like topologies are, or UV shells and so on. So we got our low poly mesh. Let's go ahead and export that as well, but we'll export that as OBJ and put it in there. Everything should be save mesh by parts, no. Export normals colors, yes. Click OK. That is exported. Let's save the project and close it. So we don't need that anymore at this point. So we got our camera registration. Let's run the script to convert it into our format. Make sure, yes, we have just a single sensor there because we did not do any refocusing or anything like that. Let's also run fix up high PLY in case if like with previous scans, in case if there's some irregularities there in exported data. So that's all done. Now also let's run marker info and specify marker size. In our case it's 7.9, and I explained how to get that in a previous video. We run marker info, so at this point it also checks the scale for us, so that's pretty close to 1000, 1.6 exposure. The distance is 490, basically 49 centimeters, so all that was modified. So at this point it's pretty much good to go. We go to solve, just check the parameters to make sure, yeah, this is what was automatically modified. Let's have a look at the resolution info script, which should calculate us and give us optimal resolution. Assuming that images are as sharp as they can be, then what would be the practical texture resolution to realize all that resolution in original imagery. So that's pretty good. Sizes look about right. Resolution is slightly over 8K, so it's 9K, so practically 8K would be a good build there in this case. And we also see that average distance from the object to the camera is pretty much the same using different methods there, so we know that pretty much there are no outliers or nothing weird in camera registration, and we checked that manually as well previously. So as a quick thing, as I said before, it's usually good to just build a quick 1K texture to overall see if there are any problems with like with those support structures, if you get some weird artifacts that require masking. In this case, even though technically there is one shot where there is a bit of overlap, but we will not see that in this shot because there are other shots with better quality that override that essentially. But in more complex cases, you'd have to do masking, and we'll do a separate tutorial just on that. And here let's wait and see while it builds everything. That samples per pixel number goes up. Usually anything above 50 for this type of thing we would consider good. For some commercial scans that we do, we try to push it like 100, 150, on some higher res and higher quality models up to 100 when you have a lot more loops there. And also more overlaps between these loops, because the more we see, the more data we have to work with, the inference engine then get better results. That are more consistent under different viewing angles and lighting conditions. So there you go, we got over 50. So quite happy with. I think we're gonna have good results. So now the main engine runs, and it's pretty much done. Finalizing, saving, now housekeeping. So that previous step took 1:40 seconds. Overall process should be under 2 minutes, I think. Yeah, almost 1:59. So at this point also, let's go ahead and do this transfer. Let's bake the AO just mainly for inspection, even though we won't really use it for rendering. However, I'll probably do a separate tutorial on using Sketchfab and how to calibrate all the shaders and textures just for that thing alone. So that would be useful there. So there you go. Let's click the preview. Blender is starting. It also does all the housekeeping setup, and there you go. Here is our prop. It's already, keep in mind, this is right now all a small resolution, very low resolution, but it's it got all the features, all the materials and everything that we need, and at least we can go ahead and inspect, like switch to more like full screen. We have kind of these little artifacts. That's because of the smaller texture resolution. Definitely 8K would not have those problems. And some stuff around these tentacles, that's where we saw some overlap, and right now, just looking at that, I don't see any obvious problems, so we might be just fine there. The bottom, so we got everything. Let's go back. Also, if we enable this extra stuff, we see that the model is standing perfectly because we do some extra alignment there. We got all our cameras imported in here as well, so we can actually go ahead and look from each and every camera what that model looks like. We can hide cameras, hide all that stuff. Now let's quickly inspect all other channels here in case if there's something weird and unexpected, especially in these roughness and reflectance maps. Overall, it looks pretty consistent. And what I would expect from this prop, and we scanned it with a lot of different settings and different ways, and so I kind of look at it right now and see like, okay, yeah, that's all good. These shiny parts, what we see in kind of shiny silver parts here, they're also bright and reflectance. These are our colors there for metallicity, and we can also look at this confidence map. So everything that you see here that's yellow, that's very good, it's very confident. Green stuff, it's when it begins and we start getting occlusions there. Also you have this kind of greenish and darkish areas around his like this, I forgot what these are called, parts of tentacles that have a lot of occlusion around them. And here this is example of those white parts where we have potential clipping or low signal to noise ratio for some areas. So when you see basically something like white paper there, the difference between white paper cross polarization components is so little that we have basically very little confidence there. So if you, in these cases, for instance on that white paper, you look at this reflectance or roughness, you would have a bit less trust there just because it was hard to observe in those cases. But overall, that's our prop. This is what it renders like with all the lights. We can obviously grab any of the light here and start moving around and see how it interacts with it. And this is using EV real-time render that's very similar to pretty much anything that's PBR nowadays, like Unreal Engine or Unity or Sketchfab. We can switch to a path traced, in this case cycles, and also see that pretty much everything will look exactly the same, and this is also compatible with pretty much anything that's PBR path trace out there, like RenderMan, Arnold, Redshift and whatnot. Most of the commercial renders are pretty much the same nowadays. So there you go, great, we can save that. We're happy with the prop. Looks great. So this we don't see any problems. So at this point it's pretty much good enough to go ahead and build our final 8K texture. So in this case the model is set up once and then it's saved right away, so the next time we open it, it's pretty much stays all the same. So in this case, now let's go ahead and start our 8K texture build. 8K build, and I'll keep it on screen and have it running, and we'll get back to this once it's done. For you it's gonna take a few seconds. Alright guys, we're almost done here. It finishes up fourth tile. So when building 8K or anything larger than 4K on this machine with this amount of memory, it would split job between various tiles. So 8K would be split into four 4K blocks. And if you can run multiple nodes on multiple machines, that process can be all ran simultaneously on multiple machines. Here you can see that all the tiles get combined. In case of multiple machines, all that would be combined on a single node, and the data is gathered from other nodes. And at this point we'll see what the final time, how much it took. I don't remember when we started this. So right now it just goes through various post-processing steps as usual, doing some housekeeping, fixing up some edges, some outliers, some doing texture UV space dilation of those UV charts, so you don't see those stitches and artifacts related to that. It looks like our last step of reconstruction process is about to finish. 99%, and it should be done any second now. There we go, filtering is complete. Normal is saved, and the rest is just regular housekeeping stuff with dilation and alike, processes alike. There you go, the whole process building 8K textures for this prop took on this machine 44 well, let's say 45 minutes. And at this point in our 8K folder we have our all 8K resolution textures, so you can see 8K 64 67 megapixel total. And in raw folder you can see that there are 4 different tiles that were used to build this whole 8K texture. And as I said, all that could be executed simultaneously on multiple machines and then gathered at the very end by a single node for final reconstruction. And that's a way to speed things up when this time between starting the build and finishing is critical in production. So once we got that, let's also run the script. This is done. So the last thing that we want to do before the data would be ready for deployment and uploading to, let's say, Sketchfab, let's go ahead and bake this AO. In a few seconds we will be ready to fire up the previous scene and see everything in its final 8K resolution. So there we just have audio telling us that we're done with that long process that took 5 minutes and 40 seconds. The total time is 6 seconds for this, but we finally have all our texture sets in here. And let's run the preview model script. At this point it's also done some extra alignment for us, so the model is nicely placed without that spacer with all nice cameras around, and this is pretty much our final resolution with 8K textures, and this is the kind of model that now is ready for deployment. Let's look a bit closer at all the maps that we got. We got our world space normal map, tangent space normal map, albedo map, specular GGX roughness map that we also can see it's pretty consistent and smooth there across the model. We got our reflectance, and we finally got our coloration that we would use. So at this point, let's also check the AO. And sometimes when you see problems with the model, it would be quite visible in this model as well. So that looks pretty good for what it is. We can also look at our confidence map, and that looks pretty good as well. And as you can see on this high-res ones, since we got more data, it's even a bit more accurate there, so we get fewer those darker areas here around his tentacles, and some greenish areas with occlusion there, but overall this is pretty good. So having those through perpendicular loops was a good thing for this type of model. So at this point we can go ahead and also check it with real-time rendering. We can switch to cycles rendering for to verify that it also works well with path tracing. And at this point pretty much the model is good to go. It's good for deployment for the final platform that we would be using for rendering. One thing though is that if you also want to have this model in this state that is properly oriented and nicely scaled included in the deployment folder, we have to go ahead and export it as an OBJ, do selection only, and go to the main root folder of this prop and call it model.obj. So we export that. Whatever the settings are, that's fine. We just export the final nicely oriented mesh. At this point we can just save the file. We no longer need it. And to go in more detail, we'll have a special tutorial on actually deploying the data and importing that into Sketchfab. But the really last thing that you do before all this data could be transferred and generated into its final production ready form for renders, we just hit deploy. And in this case, if we go to parameters under solve, at the very end we have some parameters and variables that are specific to just deployment state. And in this case we have one target enabled, which is SFAB, meaning Sketchfab, but that's essentially data that's compatible with specular pipeline. And if we want something extra there for older pipelines that use Metallic, we can enable Unreal Engine 4, and that will be compatible with that, and it will generate the whole set of models for that as well there. So nothing much here as well. There is some quality for JPEGs. We try to pretty much keep it close to 100% when deploying to Sketchfab, but there are TTJ versions of those textures available as well. So this process should go pretty quickly. Again, it mostly has to do with various sorts of dilation and making sure that when all those textures are MIP mapped, there are no issues around the edges, so it makes sure that all the data across there blends consistently and generating the final sets of images. So it took me a minute and a half, and under this deploy folder we could see that we have TGA folder. This is where all the final textures are that are uncompressed. And if we go to SFAB, this is typically what we would upload to Sketchfab and other things like that. So we would have our low poly model that's already nicely oriented in here. That would also have those original UVs there, and it would have all the textures that are named properly for use, let's say in this case with Sketchfab. So we have our albedo, we have our AO, tangent space normal map, roughness map, and our specular map that's colored. So in this case there is no explicit metallicity map because everything is handled essentially by this map. We'll have a video that where I will show how to use this specific set of texture in this exported model to put it on Sketchfab and make sure that it looks exactly the same the way it looks in Blender or any other renderer for that matter. We have a special video that goes in a bit more detail on how to calibrate all this data with different shaders and setting up all the shaders and making sure that all the data is interchangeable, but we'll have a separate one just on Sketchfab as well, just because we use that a lot for demo and also for business purposes. At this point we're going to conclude this video part. For you, a lot of these different steps that took a while here would take just a couple of seconds, so we'll speed all that up, and I will see you in the next video.